we're given y is equal to 2 cosine of x plus 3 sine of x. Okay, so determine the stationary point. You need to get the derivative of the function here. So that gives what? It's negative 2 sine of x plus 3 cosine of x. Yeah. And then this thing is equal to 0 because we're looking for the stationary points. All right. Okay, so if you're finished, please submit in our group. What was your subject before? Oh, it's physics. Okay, okay. Okay, so anyone just finished? What's the stationary point? What's the stationary point of this question? Okay. How do you finish? All right, thanks. So this is very similar to the question a while ago, class. Okay. So this one, so you have a negative 2 sine x plus 3 cosine x. So that's your first derivative. So we need to solve for x on this one. Okay. So what I'll do here is bring in 3 cosine x transpose 2 sine of x, and then I'll just solve for x. Okay, so basically, okay, I'll remove 2 first. So we have 2 here, and then I remove cosine by putting it here. Okay, so you have 3 halves, or 3 over 2 equals sine x over cosine x is tangent x. And then how do you solve for x? So it becomes inverse tangent of 3 over 2 equals x. So please use your calculators. Hi. So your answer is 0.98 to 8, right, for significant figures. Right. So this is your x value. Right. Now to get your y value, just you know the drill, right? So y is equal to 2 cosine of, instead of x, you put 0.9828 there, plus 3 sine of 0.9828 again. Then just type it there on your calculator. Okay. So you got 3.606. Okay, again for significant figures. Okay, so that's your stationary point. And now, how about, yeah, until 12:30. And then, what's next? How do we tell if it's maximum or minimum point? We get the second derivative. So that gives us so over. So for my second derivative, it's equal to so it's negative 2 sine x sorry, minus 3 of sine x. Okay, and then just plug in here our x value. Okay, sorry, this is when x is equal to 0.9828. So what's your answer? Just plug it here. Minus 3 sine of 0.9828. So our final answer is, again, it's a negative. Okay. Okay. So we're just looking here. I mean, we're just finding if our final answer is a negative. Since it's a negative, I know that this one is a maximum point. Okay. So yeah, that's it. That is number 14. Okay. All right. So that's number 14. How about the rest of you guys? Okay, class, please take a photo if you're finished or not. It's okay. I just need to see, like, okay. So let's have another example. Okay, so this is number 14. All of them are similar. Okay. So this is number 14. Can we jump to page 400, 404? I just want to explain one more question before I dive to the tangent and normal of a curve question. Okay. Number 7 on page 404. This is number 7. Okay, on page 404. I just want to explain this one. Okay. So the gradient, find the gradient of the curve. Okay. This is page 404. So we need to find the gradient of the curve at y is equal to 3 plus tangent 2x at the point where x is equal to pi over 8. X is equal to pi over 8. Okay, so again, to get the gradient here, basically we just need to get the first derivative, which is 2 secant squared of 2x, right? And then how do we get the gradient? Okay, so to get the gradient, we just plug in this to the x value. So that gives, wait, let me write that here. So when x is equal to pi over 8, gradient is equal to 2 secant squared of 2x. So 2 times pi over 8. So what's your answer there? Okay, by the way, class, there's no secant squared x in your calculator, right? So what is one way of typing that in your calculators? How do you type that? Secant squared x. So you can either type in tangent squared x plus 1, or yeah. So we can factor out that as 2 tangent squared. So instead of 2x, we're going to write 2 times, let me make this x first. So this one is 2 times tangent squared of 2x plus 1. So that gives 2 tangent square root of 2 and then pi over 8 plus 2. Okay, so what's your answer now? Hello, Segwar? You guys there? Okay. Alright, so that's what? Pi. Alright, so your answer is? What's your answer? The answer is 4. Okay, so the gradient here is equal to 4. Okay, so that's number 7. Okay, class, so I'll share this again in our group. Just want to explain one more question. Okay, this is my very last one about this chapter here. Okay, this is my very last example. Okay, now this one, can you guys please turn your books on page 396. Okay, again, page 396. Okay, again, page 396, because I just need to explain this question because I saw this in the previous exams before. So they ask something like this. Okay, so the question is this: the tangent and normal to the curve y is equal to sine x at the point or at point P, okay, where x is equal to pi over 3, cut the x-axis at A and B respectively. Now, for letter A, you need to show that AB is equal to 5 root 3 over 4. And then for letter B, find the area of the triangle PAB. So this one came from your book. Okay, so let's do letter A first. Because letter A is the trickiest question here. Okay, AB is, okay, it's the distance, okay? It's the side of this one here. Okay, we're looking for the distance. Right, for letter A, we know that x is pi over 3, okay? So, plugging it in our equation, which is y is equal to sine x, from our question there, again, the equation of the curve is y is equal to sine x. So what do we do here? So we just plug it here, okay? So our y is pi over 3, okay? What is pi over 3 in radian? I mean in your calculator, sorry. Sine of, if you type there pi over 3, it will give you square root of 3 over 2. Okay, please type this in your calculators. You'll get y is equal to square root of 3 over 2. All right, and then okay, so what is the gradient of this one, right? So to get the gradient of this, of this one, so we need to get the derivative of sine x, which is equal to cosine of same pi over 3 is equal to 1/2. So the gradient of your curve okay, is 1/2. Again, this is your equation. This is the first derivative because we need to look for the gradient, okay, of the tangent line, okay, of this at point P. So we need to find the gradient from there. Okay, so plugging in pi over 3 here, that gives you 1/2. Okay, now the question is, what is tangent and normal to the curve? Okay, we know that a tangent is a line intersecting a curve at exactly one point, right? And this is your equation for that. Sec 4, do you still remember this? Okay, this is your gradient point formula. Did you have this when you were in Sec 3? Sec 4? Anyone? Sec 4? You guys there? Did you have this? Do you remember?
No.
Do you didn't have this? Okay. Okay, anyway, let's okay. Now we use this formula, okay? We use this formula when we are given gradient and uh, a point, okay? Just one point. We just need one point, right? In this case, our point is point P, okay? Okay. Okay, so the coordinates of our point P, by the way, again, the coordinates of point P is pi over 3 and root 3 over 2. So this is your x, this is your y of point P. So therefore, we can use this formula, or we will use this formula. Okay, so again, this is for the equation of the tangent line. So again, x sub 1 and y sub 1 are your x and y's here. And then your m here is your gradient here. That's what we did before, right? So we just plug everything here on this equation right here. So it becomes y minus root 3 over 2 from our y value. This is the one that we solved a while ago. Equals, why is this 1/2? Okay, this is 1/2 because our gradient is 1/2 from here. Okay, and then x minus pi over 3. Okay, why is it pi over 3 again? Because that's our x value for point P. All right. So therefore, this is your equation for your tangent line. This one, for this line here. Now, what we're trying to do here is how do we find the coordinates of point A? There. How do we find the coordinates of point A? Now, to find that, we know that if you observe class, point A is lying on the x-axis, right? Now, if your point is on the x-axis, what is the y value of this? The y value of this point is 0, right? Because it's on the x-axis. So look here, I'm right here. So the coordinates of A here, we know that again, it's y is equal to 0 because the point is on the x-axis. So therefore, you just plug 0 here, class. That's it. And then solve for x. Okay. So instead of y, it becomes 0 now. And then minus root 3 over 2 equals 1/2 x minus pi over 3. So class, just solve for x on this one. Okay, so how did I solve for x? I know that my y is 0, so this one, solving for x, my x is this, pi over 3 plus root 3. Okay, so how did I get this? Let me explain this, this part right here. So 0 minus this is basically, root, okay, so root 3 over 2. So I forget to put my negative sign here. Okay. And then equals, so this one is, you distribute this. That's why you got a negative, sorry, half x minus pi over 6. Okay. All right. So, and then, okay, solving for x here. So since I have fractions here, okay, so I need to remove those fractions by multiplying everything by 2. Okay. Because I need to remove, because your x here has 2 as its denominator. So you want to remove this 2. So in order for you to remove this 2, you just multiply the whole equation by 2. So you can cancel this out. But then you need to multiply pi over 6 and root of 3 over 2 with 2. So therefore your x value is pi over 3 plus root of 3. That's your x value. So the coordinates of your point A is uh, pi over 3 plus root 3 and then comma 0. So class, this is your x and then this is your y. This is just for point A. Okay. Take note, this is tangent of the line. All right, so for our next one, okay, so we're done with tangent. So let's go to the normal of the curve. Again, class, the normal of the curve is the line perpendicular to your tangent. So this straight line here. Okay, this is perpendicular because it makes a 90-degree with your tangent. Okay, so what we're trying to do here, class, is we're trying to find the coordinates of point B. So, but before we go there, what is the equation of normal of the curve? Okay, so it's, class, listen, it's basically the same thing. It's just that, look at your M now. Okay, it's the negative reciprocal of your gradient. Okay, do you still recall this from Sec 3? This is a negative reciprocal of your tangent. If your tangent is m, your normal is negative reciprocal, so that's why it's a negative 1 over m. Okay, so from 1/2, it became negative 2. Do you have any question? Because if you plug it here, so you have negative 1 over 1/2. So that gives what? Negative 2, right? If you plug this in your calculator, you'll get negative 2. That's why you have negative 2 here instead of having 1/2. And then everything else is the same with this. Okay, it's the same. Okay, because it's, yeah, point P is the same thing because we're still referring from point P. So point P is on negative yeah, pi over 3 and root 3 over 2. All right, so how do we answer, how do we find the coordinates of point B? Okay, so to find the coordinates of point B, we know again that point B is on the x-axis. So therefore, y is equal to 0. So just plug in 0 here. So again, it became 0 minus root 3 over 2 equals negative 2 and then times x minus pi over 3. So solving for x here, okay. So what happened here is I transpose this on the left side. That's why I get negative root 3 over 2, and then I have negative 2x. So if I want to solve for x, I divide both sides by negative 2. So therefore, my x is, by the way, if you divide this, you will get pi over 3. If you divide this, you will get root 3 over 4. You can use your calculator for this one, right? But you need to do them one by one. So your x coordinate for point B is at pi over 3 plus 3 over 4. So this is your coordinates for point B. So we now have the coordinates of point A and then point B. So what's next? From the question itself, show that AB is equal to 5 root 3 over 4. So this is what we're going to do here. All right. So to get the distance between those two, okay, I'm going to subtract them. Okay. Okay, so the distance between A and B. Okay, so this one plus or minus this one. All right, so again, class, so where did I get this? I got this, okay, from my B, okay, and then minus this, okay, from my point A, okay, point A. Take note, this is minus. Sorry for that. This is minus 3. Okay. All right. So subtracting them gives me the distance between A and B. Okay, so basically you just need to simplify this. Okay, so removing the negative sign, everything here becomes the opposite. So this is negative pi over 3, and then negative times negative root 3 is positive root 3. And then, so what do we do after this? We get the least common denominator, which is 12, and then dividing each by this. Okay, so you get 4 pi. All right, so again, 12 divided by 3 is 4. 4 times pi is 4 pi. 12 divided by 4 is 3, so that's why you have 3 root 3 here. And then 12 divided by 3 is 4, so again, you have 4 pi here. And then here, since this doesn't have any denominator, so 12 divided by 1 is 12, that's why you have 12 root 3 on that part. And then just simplify this. Okay, so this 2 here is equal to 0, right? And then you have 3 root 3 plus 12 root 3. Since they have the same roots, we can add this and this one. So that's why I have 15 over 3 over 12. Or when you simplify that, that becomes 5 root 3 over 4. So that is just letter A. That's showing that AB is equal to 5 root 3 over 4. Okay, I know it's too long. Because the book here, it has too many shortcuts. But if you get what's on the book, it's totally fine. Okay. And then for letter B, it's just asking for the area of the triangle PAB. So it's basically half times AB, right? So this is your triangle. So this is your base, which is 5 okay, over 4. And then the height is what? The height is 3 pi, root 3 over 2. This one. Because this is root 3 over 2, right? This one. So this is the height of the triangle. So root 3 over 2. Okay, so root 3 over 2. It came from the y value. So just plugging this in your calculator, you'll get 15 over 16 square units. Okay, so class, I'll upload the video of this one in our group.